Hi, ni hao.
Hi.
Hi.
Hi. Welcome to Taiwan.
Thank you.
I was about to send you a message, but I figured you need
Oh yeah, no, we're all good. Hi. Hi. Arne.
What's going?
Good.
Alright. Cool.
So, does everybody kind of know each other, or is it more like a loose group?
I came once before. Some people a little bit.
Yeah.
Not everybody.
Yeah, I think a lot of people only know each other from the chat group.
Oh yeah, right, the Telegram. That's pretty active, huh?
Jinxuan Wulong.
哦，真的吗？
真的，
谢谢，我很喜欢喝茶。
冰的可以吗？
可以。Yeah, I have let me show you, just start with the important stuff.
That's the stickers. We have a sticker. We have several stickers. Okay, I see.
So it's mini display port, but I also have an adapter for HDMI.
We also have an adapter for the
Yeah, or there's actually a
because the VGA, but actually VGA provides it more clear because it is 1024 times 30 is 68.
So use this one on the VGA because I have a VGA as well.
Okay, use VGA.
Yes, it's VGA. Yeah, right.
Yeah, please.
Right. Y'all can pass these around.
后面一点点。
These are like little booklets.
Alright.
一个在直线上。先用5伏特电源。
啊，5伏特电源。
对，我在想说一个拍前面，一个拍讲这，就不用斜着了。
电源，你是说行动电源？
对，就没有了，就是
线，
就是
啊，接那个
110转5。
哦，懂意思。
有吗？
哦，我看一下。
哦。
可以看吗？
动作是
110转5伏。
苹果的吗？
对，不用，没有，不是，就 USB 的那种。
就是 USB 充电器，一般那种头就可以。
对。
可以接到。我想看这个是可以用啊，但是我想看别的东西。我看有没有？
因为如果有的话，我就一个。
我们有3点联动。
这可以吗？可以。
可以。
哎，我
因为有的话，我就一个就直接拍荧幕，然后另外一个直接拍讲者。
可以这样子啊，上面就有了嘛。
哦，好，那就不要。
那是我的。
OK， 很感谢。
这还不错。
竟然有这么好玩的东西。
Chair here because I'm gonna have to do a little bit of demo stuff and it might be easier to sit. Do you guys mind if we do like, I don't know, maybe just a little bit like what we usually do, but like do a little round of introductions because like it's a small group and then, you know, it's kind of nice because I'm also here to meet you, right? So let's just like sort of say, you know, who you are, what your story is with Clojure, and maybe like one fun fact about yourself. So hi, I'm Arne, which up by Aaron. I've been doing Clojure for a couple of years. I do this Lambda Island, so I make videos about Clojure. You might have seen that. Before that, I mostly did Ruby, so I'm kind of coming from the Ruby world, but now I really focus heavily on Clojure. And fun fact, I very much like Taiwanese tea, and I can juggle 4 balls. So you want to...
Nice. Should I turn around? Sure. 你好，我是 Jonathan。本来在写 C++ 的东西，然后 about a year ago，开始找到 Clojure， 然后开始玩了一下而已。So mostly hobby projects.
很好。Anyone?
Okay. Hi, my name is Jinxuan. Can you call me Kibura? I'm Taiwanese, not Japanese. But
Okay.
I got a nickname. Yeah.
Cool.
I'm a iOS developer, iOS mobile app developer, but I'm just Clojure rookies. Yeah, just learning stuff.
Just
yeah.
trying it out.
Yeah, just try. Yeah.
Cool.
Thank you.
All right.
Continue.
I'm coming. I'm
就国语就可以。
中文我不知道讲什么。我基本上Clojure台湾的就群主创作者之一了。但是因为我工作已经离Clojure越来越遥远，所以我现在大概就是把它当 hobby job 在写。
对不起，你刚才说叫什么名字？
啊？
叫Cody。Cody 哦。
好，谢谢。
Hi, I'm Joanne. I followed Arne here. I live in the U.S. I'm mostly a Python and JavaScript developer, but I'm slowly switching over to Clojure for some of my side projects. Mostly work in web applications rather than data analysis and visualization. That's really it. Just a fun fact about me.
Okay, nice. 好，还有人要说什么
Okay, may I have to introduce the space here.
Yeah, that would be great. Yeah.
Actually,
我们2点半再开始。
2点半吗？
对，表定时间是2点半，所以你可以先介绍完，但是等一下这个 talk 可能2点半，先让他们介绍10分钟。
哦。
对，介绍这点，因为有些人第一次来，所以要介绍一下。
Yes.
Okay.
So may I ask how many people are new here actually?
第一次来。
Okay.
第二次来。
第一次来。
第一次来的。
Yeah.
First time here.
Yeah. Okay. So you couple? Sorry, are you couple?
Yes, yeah.
Okay, so I'm Yao, and actually I'm over at work, and I actually do something Debian at rest of the time.
Oh, nice. Yeah.
And also I'm one of the keyboarders here. So if you want to record some events which is related to open source and culture, it is free.
Oh, very cool. Thanks.
Hi everyone, I'm Randy. I work and I was a JavaScript developer before, but right now I do a lot of things about not related to JavaScript because some of language issues I don't like it. And I made Clojure because I joined React events years ago, and I met David Nolan, who was famous in the Clojure community, and he gave a talk about the Clojure. And then I met somebody else really dig Clojure job in US, but he's a Chinese, and we communicated a lot and introduced some talks famous in the Clojure community like Rich Hickey's talk, Simple and Easy, and then I get interested in this language and the community. But right now it's still not my daily jobs. It's still my hobby's language, but I still want to take this in production in the future days. So I also check your website because your years ago it's not so famous about functional programming stuff, and your website is very easy to Google it.
Right.
So I read your talks a couple times, and it's really helped me.
Oh, great. That's really nice to hear. Yeah.
Yeah.
Yeah, I haven't set it up yet, but I can share a discount code if anyone want to check out the videos. You can easily do that, be happy to do that.
I don't remember your name.
Randy.
Randy.
Yes. Nice to meet you.
What's my turn?
I think so, yeah.
My name is Vincent. I am originally from France. I lived in Taiwan for 15 years.
Wow.
I have a family here, so I'm a permanent resident. And I was a game developer most of my life. I stopped a little more than 1 year ago, and I moved to web development. And the reason why I moved to learn Clojure is because I really loved to use this key when I was a student in the university, and I was very happy to find it again in the web development. So I'm learning it actively now. This is still a hobby now, and I hope in the future to keep my job.
Yeah.
That's it.
Does anyone know of any companies in Taiwan that use Clojure?
No.
Nothing really, right?
Not yet.
Render? You mean the 3D software?
Clojure, yeah. I find it surprising because it's like you start to see it more and more in other places, but here somehow, I don't know. I guess maybe is it more conservative IT culture, or because there's a lot of Java, right? Or like what are sort of the big languages here?
Yeah. I have to say, not a whole lot of learning resources in Chinese. It's in English.
Yeah. I mean, there's some stuff happening in the mainland. Like I see the Chinese Clojure forum is very active, and they try to translate some. So then it's in Genti, but at least it's in Chinese. Like All right.
Would you mind adjust your output of the computer because it is a little bit offset?
Okay. You mean
the projector is actually in the center. So.
Okay, let me see what I can do.
Wow. I see your input.
而且这个 projector 亮度可以调高一点。
亮度
还是
我记得已经是如果再更高的话，可能会把简体可能会就是它会调它的
是会糊掉，是不是？
它会调它变成那个另外一个，就是亮度提高的话，看起来可以，看起来可以。可以。
I mean, I can also.
Could you try 1024 times 1768?
Which one?
1024 times 1768.
Yeah, but if I need to demo stuff, that's going to get very small. Can we do?
Okay.
I mean, okay. Also, my presentation is widescreen. Yeah, I guess that works.
那个我刚刚讲亮度调高会变这个样子。
We can do it this way. That's fine.
Sorry. I can just adjust the brightness down a little bit because it is.
Oh, right. So you actually see the picture, yeah.
Yeah. 这样子可以吧
Yeah, it's good. So we start at 2:30 and then I'm
2:30.
Yeah. Okay. Sure. You can pass these around as well. Just take as many as you like.
Okay. May I put a speaker?
Yeah. Sure. Absolutely.
最近不跟我讲话，找不到他。
你说啊，对。对对对。
因为自己看不到那个。I'm just trying to like figure out who's who.
Maybe you see Vincent or Green could have.
Yeah, no, yeah, I do see you. No, yeah, you have the picture.
Question.
Sure.
Why you choose Lambda Island as your side project?
The name or?
I mean because you can choose many different topics because Lambda Island is for tutorial for teaching other people to use Clojure.
Yeah.
And I believe, of course, you have found many different topics that is interesting enough to devote your energy into it. Why you choose the job of teaching others, like a teacher?
So
just interesting.
Yeah, no, it's a good question. It's a good question. It's basically so.
Because you feel that to feel people use Clojure, so you have to evangelist.
I mean, there's partly that, but it's more. It's like I'm doing Lambda Island because I think it's a good combination of the skills that I have. So I'm reasonably good at programming. I'm reasonably good at explaining things. So I have experience doing workshops and this kind of stuff, and I very much enjoy teaching people. And so I found that sort of, yeah, it's something that sort of brings those things together. I have experience with audio and videos, so that's sort of, you know, another thing that I can combine. So I figured that this actually, it brings out all different parts of my experience, of my skill set. I also just find it very satisfying to be able to, you know, like bring others to a higher level. So, you know, because yeah, if you're just, so I mean, I also do freelance development. I also enjoy that. I also just like writing code, you know. But yeah, working more directly with people and you know, trying to have impact on other people, I find more satisfying. More, yeah. I guess that's sort of the answer. Does that answer your question?
Actually, I do not expect a correct answer or a right answer. Because I'm recently thinking about this kind of problem. For example, there is a guy very famous in this island, the Paul Graham. He even created his own list called ARC. But actually, ARC, I never use it, but I personally believe that ARC is not usable as Clojure. But for my point of view, Paul Graham is very, very good at writing essay. But maybe he is not as good as creating new programming language. And on the other hand, that is just something like that. You explain that because your skill set is good at teaching others, and I believe that maybe Richard is good at creating good programming language, and maybe he is not as good at writing essays.
Yeah, that's a very good point. Yeah. So That's more or less it. I mean, really, I was just looking for something like because before this, I was doing contract work. I was just a full-time programmer, and I really wanted to start my own product. I wanted to have something that I could sell, to build a business around. And I could have done a lot of things, and this was just something that seemed like, a good idea and something that I would enjoy doing. And it's been a lot harder than I thought it would be. Clojure scene is very small, so there's only a small market, and that's been tough in the beginning to get enough people to actually sign up. And it's still like now I'm still combining this with freelance work and with freelance coaching, because Lamb Island itself does not make enough money for me to really live off. But it makes some money, and it's getting there, and I get a lot of positive feedback. But that's been a tough lesson, that like, okay, maybe I'm a good teacher and a good programmer, but maybe I'm not such a good businessman. Maybe that's something I'm still learning. So that's been kind of the interesting lesson from all this. That like, okay, purely from a commercial perspective, maybe I should have done something else. But I'm happy with what I'm doing, and I'm still looking for ways to. I actually have some new things that I want to do this year with Lamb Island. Can't really say too much about it yet, but it's probably going to start being more stuff than just the videos. So still kind of figuring that out. Okay, 2点半到了。
Yes. 都是介绍下面。
对。好。我快速在这边介绍2分钟，大概1-2分钟以下。好，这个大家很明显的知道，这里是 Mozilla 的 Community Space Taiwan 台北，然后就是这里是一个由 Mozilla Foundation sponsor this place, and actually, we have a good neighborhood which is called OCF.tw upstairs.
And what is
OCF.tw is actually for open source communities.
Okay.
And actually an entity for open source communities.
Right.
Yeah. So and if you and this place is actually for open source, open culture. It's dedicated for them. So if you want to hold an event about open source or open culture, it is free here. If any one of you needs Wi-Fi, the password is FOX-MOSA.
It's actually a good point. Maybe I should also connect. Oh, maybe I don't need it also.
Okay. So if you guys need the toilet, it is right behind the door. And the all donations, and it is all, you can donate coins and banknotes just in front of the entrance. There is the box, donation box. 捐款箱. Okay. So so time's up.
Yeah. All right. Thank you. Yeah, 大家好. Thanks for having me. So this is basically a talk that I've been thinking about and that I'm hoping to submit to some conferences this year. So you guys sort of get the first version, which is cool, which is exciting because you're the first to see it. It also means that it's still a little new and maybe there's still room for improvement. So I would be happy to to discuss stuff or to answer questions. You can interrupt me anytime with questions. I don't really mind. All right, yeah. So let's get started. So today we're going to talk about REPLs. Does everybody know what a REPL is?
We use it every day, right?
Yeah, we use it every day, right? But before we talk about REPLs, I actually kind of want to take this metaphor of a workbench, 工作台. So Wikipedia says that a workbench is a sturdy table at which manual work is done. They range from simple to complex designs that may be considered tools in themselves, and their size and design varies depending on the type of work that is being done. Okay, that's clear enough. Wikipedia also says that it's a place where you put the thing that you're working on. It gives you access to your tools. You want to reach for your screwdriver or your hammer, like that's right there. And it lets you work comfortably. Maybe you want to work sitting or standing, but it's sort of, things are You can work in a good, comfortable way without hurting your back, right? So what would a workbench be for a programmer? Okay, well, it's a place where you put the thing that you're working on. It gives you access to tools. It lets you work comfortably. Also, it can range from simple to complex. It mentioned that at the beginning. So what would a programmer's workbench be? Anybody?
REPL?
An editor! So there I tricked you. So yeah, this is, right, we write software in our editor, right? That's where we put the stuff that we're working on. But your workbench needs to give you access to your tools. And what's the most important tool, especially as a Clojure programmer, as a Lisp programmer, what's our main tool? Well, our main tool is our REPL. Not just because it's a good tool, but because it's a meta tool. It's a tool that gives you access to tools, and it's a tool that lets you build your own tools. So it's not just one tool, but it's sort of a gateway to all your tools. So this is a Clojure REPL. This is a real Clojure REPL. You can put that in a file. This is all you need. Of course, the actual Clojure REPL, you know, there's a prompt and there's error handling and there's all kind of stuff. But this is basically all that there really is. There's read, eval, print, and then in an infinite loop. So there's those three inner parts there. First we have read, which is really just a function that takes a string and turns it into data in a data structure. Now there's two versions here because one reads from a stream of bytes and the other reads from an actual string, but it comes down to the same thing. You're transforming, you're going from the land of strings, from the land of text, to the land of data structures. And then when you have that data structure, well, we're dealing with a Lisp, we're dealing with Clojure, which means that your code is represented as data. It's the same data structures that you program with are also used to represent your code. So that means that you can treat that data as code, and you can say, okay, now eval that piece of data, which is now considered code, and you again get data back. So read goes from string to data, eval goes from data to data, and then finally we have print, which goes from data back to string. Again, two versions, one goes to an output stream, the other goes to a string, but it comes down to the same thing. And so notice that read and print are kind of each other's opposite. So you can go, you can take something and like read it, print it, and you get the same thing back. So you could even say that like, the combination of read and string is kind of a poor man's identity function. I can redefine Clojure's identity. I would actually get a warning if I tried to do this, but you can do that. And yeah, that works. So these are really just sort of each other's complement, right? You can think of this as constantly transforming one into the other. Keep that in the back of your mind. We'll get back to that later. Put my cursor out the way. Okay, so what do we use this REPL for? There's a bunch of different things, and I just kind of want to go over this to give you a sense of, okay, well, this REPL, yeah, we think of the REPL, but it's actually, depending on where you are in your workflow, what you're working on, there's all kind of, which REPL you're using, there's all kind of different things that you end up doing on that REPL. So one typical thing is to explore Tom's tools. So say there's, I want to use the Slack API. I want to retrieve a list of users and do something with it. But I've never used a Slack API before, and I don't just want to write 100 lines of code in a file and hope that it works. No, I want to try it out first. So okay, I require this. According to the README, I need some kind of connection map, and then I call this API and I store the results so I can look at it. So let's see. This is a list apparently that I get back. I know it's a long list. Okay, there's all kinds of stuff in there. That's why maybe it was good that I didn't just print it out on the REPL. Let's see, what's the first thing in there? It's a map. So what's in that map? What are the keys in the map? Oh, okay, and now I'm starting to get somewhere, right? And now I can drill down into that profile and see what that is, and maybe try to write a little function and see if it works with the data that I got back. So you can sort of explore things, figure things out. You can observe your system, see what's happening. Like, oh, what are the parts in my system? How much memory is Java using? Or what roles does the user plexus have? So I can sort of ask the system questions. I can control the system. So if you're using some kind of reloaded workflow, you can say, okay, you know, start my web server and everything else, or do like a reset where it shuts everything down, reloads your code, starts it all up again. Maybe you have some kind of worker pool, so where you want to add some worker threads, or you want to enable maintenance mode. And so these last ones are interesting because where would you do something like this, enable maintenance mode? Not necessarily locally, because that doesn't, like, you know, you don't really mind if it's like if it's maintenance mode or not, but that's something that you could do on your production server, you know, connect to the REPL there, switch on maintenance mode. Maybe there's like another thing that you can do that you don't need to add extra UI for. You can change your program, which, you know, you can like define and redefine functions, you can update pieces of state. So this last one is interesting because that's stuff that I actually sometimes do for Lemma Island when it's like, you know, I realize that, oh, actually in this one combination, if you're logged in and, you know, you're this and that kind of user, then this one thing is rendering incorrectly because I wrote this if in the wrong way. Okay, I don't have time now to roll out and test the proper patch, but I can test this one function, connect to my remote like production REPL, redefine this function, and like, oh, it's patched until I get the time to actually upload the proper code. This is of course something, you know, like, this is not suitable for everyone. Like, I'm not a bank, I'm not a 1,000-person corporation with, you know, with processes, so I can do that more easily. But sometimes that's actually a totally valid thing to do. And so all of these things together, like all these different things that you do with a REPL, are in the end used to create. You're creating code, you're creating tests, maybe you're creating data, spitting out CSVs or even files, but it's a creative process, right? And so like you're using all these things in that process. Now let's get back to that workbench idea. So your workbench should provide handy access to those tools that you use to create. You don't want to walk to the other side of the room every time you need that screwdriver and then you put it back and then, you know, like next time you need it, you walk to the other side of the room. Like, no, and so similarly, you don't want, you know, here's your REPL, here's your editor, and having to switch back and forth the whole time and copy stuff from one to the other. Like, no, that's not cool. That's not convenient. So you want a REPL that's connected. So it looks a little bit something like this, right? So like you have code in your editor, and you select some kind of code in some way and say, okay, now it's going to be read. It's going to evaluate it in my REPL, and then the REPL is going to print it. But there's two questions. How do you select which code, which form of code is sent to the REPL, and how do you decide where the output goes? And so there are several options there. So I have my REPL at the bottom, and I have some code at the top. And so, for instance, like the most basic and the thing that people, you know, back when things like CIDR were a thing, the main thing that you got is that you evaluated the form, so you would send it to your REPL and the result would pop up there. What you get with more modern systems is that it kind of shows you this in an overlay, or maybe at the bottom in your echo area, the result shows up there. But you should also, and this is actually a very important part of the stuff that I'm talking about in this presentation, you should be able to, yeah, I'm not used to Spacemacs, to evaluate something. To evaluate something and, come on, yeah, have the results show up right there, right? Like if I want to do something like this. Because that way I can immediately do something else with it. There's other options. maybe sometimes it's also actually useful to have it be inserted as a comment. So you can kind of see like, oh, you know, here maybe put some examples of what this does and then what the output is. Maybe you want to put that in a comment block at the bottom of a file so people kind of see like, oh, this is what that does. Or maybe you want to evaluate something like, say, take that list, you know, if I'm like CLJ select users list, and this returns 12,000 users. Well, maybe I actually want a shortcut to say like, evaluate this, and then ask me which file I want to save this in. Similarly, that's for where the output goes. Where the input comes from, where you also have several options there. So say my cursor is here. You see that there at the beginning of line 5? So I kind of have two options here. I can evaluate the outer form, or I can evaluate just the thing right before my cursor. Sometimes you also want to say, actually evaluate the current selected region. Although that's, I think it's superior to try to use things that are aware of your Lisp structure, such as these operations. But so you have several options there as well. Or you can say, evaluate the complete buffer. So these are kind of different things that you should have at your disposal. So your input can come from before the point, the form before the point, the outermost form, the surrounding form. This is something that, it's not part of Cider, and it's not something I have seen very often, but I have a colleague who showed me that he does this a lot. So evaluate the next bigger form. So if your cursor would be there on that one, then it would evaluate this form, which I can imagine can also be very interesting. And then yeah, evaluate the whole buffer, and then also for your output, where does your output go? Well, it can go to all these things that I pointed out. And so remember how I talked about, you know, how read and print are kind of each other's opposite, and so if we do this, we kind of end up with this loop, right? It's like, okay, we can read something, evaluate it, the result gets printed, and by inserting it back in a REPL, in a buffer, in a file, it can be read again later, and so that way it kind of really becomes part of your programming. Like you can say, you know, like, show me all those keys in that map, and then, you know, like, okay, let me say that name Arne ID 100 handle flexes. Say that that's something that comes back from the Slack API, but actually it's like it's 12 different keys. Well, maybe then I want to do something like this, like say, okay, I got this, take the first of that, take the keys of that, and then map it so it just becomes strings, and then map it to symbols. This needs to be a deep thread in them. Because now I have those 12 symbols there, so I can do something like keys, right? And now this is part of my program. And I'll get to some more sort of practical things that you can do with that. So yeah, this is again this loop, and there's several options. So I'm mostly showing Emacs because that's what I use and that's what a lot of people use. But you don't need to use Emacs because Emacs is a very old and very complicated piece of software, and it can be very demotivating if you're like, okay, you know, learn this complex language, this Lisp, which you've never seen before. Oh, and also learn this complex editor with like some really weird stuff in it that goes back 30 years. So, you know, if people are learning a new programming language already, I usually don't tell them to learn Emacs at the same time. You know, pick something that you're more familiar with. So Atom is a good choice because it's a little bit more modern. It's a little bit more like, you know, copy paste works the way people expect it to. Cursive's great, based on IntelliJ. There's also options for Vim. So I've been sort of encouraging people to use Spacemacs, which is kind of Emacs, but with a Vim emulation, and it's really nice. And I know some Vim people that switch to Spacemacs, and I know some Vim people that are like, well, I tried it, it's not Vim, I'm going back. So that's fair enough, but there are also options for Vim itself. And it can be a little bit more tricky to get them set up, but they do work well once you get them set up properly. And then yeah, Nightcode is also worth mentioning. That's what we use at the Clojure Bridge workshops. So we do these workshops for beginners, and we tend to use Nightcode with them. It's written in Clojure, and it's very beginner friendly, and it sort of has, you know, everything out of the box. So they don't even need to install Clojure separately or Leiningen separately. You know, just install Nightcode. You can say new project, start. You get your REPL, like everything works. So it's actually quite nice for beginners. Okay, so that's kind of the first part of this presentation. Just to kind of, you know, get that idea in your head that like, actually, yeah, this REPL, like it's not a one-way street. You know, you wanna have that feedback loop and reuse those results. The rest of this is sort of some practical tips of, okay, if you're already using your REPL, if you already have a REPL-based workflow, what are some of the things that I think can maybe make that better, or some ideas that you maybe want to try out. Now this is, do you guys know Clojureverse, clojureverse.org? It's like a forum, a discourse forum online. We had a really long discussion there where everybody shared their workflow, and the main conclusion is that everybody does it differently. You know, there's a million different ways that people have Clojure workflows. So maybe some of this stuff you're like, no, I do it differently. I mean, that's fine, and I'm happy to, you know, to discuss that. But these are just sort of some ideas that I found really useful, and that I've also sort of shown to other people, and they're like, oh yeah, this might be a good idea. And I'm still trying to figure these things out more, because I think we need the fact that everybody does it differently. Like in a way, it's a good thing. In a way, it's a powerful thing. You know, okay, you know, it's an individual. Everybody can do it in their own way. But maybe it's also a sign that as a community, it's not something we have talked about enough yet. Because if we would talk about it more, maybe there would be certain things that kind of float to the top, right? Where like, oh, this is actually a super good idea, you know, like, and maybe if we talk about it enough, then soon 90% of people will be doing it. So that's kind of an open question. So my first tip is to create a user.clj file. Who has a user.clj file? Does anybody know what I'm talking about? So one hand there. So it doesn't have to be called user.clj file. That's what it says at the bottom in the small print. It may also be called something else. But basically, if you're using Leiningen, so you know that if you start a REPL, say, so nowadays with the Clojure development tools, it's actually become really easy to start a REPL. If yeah, I can tell you what happened there. So here's my REPL, and you see that it starts in the user namespace. Yeah, it's a little bit low at the bottom there, but yeah, so I'm in the user namespace. That's the default namespace that Clojure starts in. Now, if on your class path there's a user.clj file, then if you're using the Clojure development tools, or if you're using Leiningen, then they are going to load that file. So I have here a source user.clj. Actually, in real-world projects, you probably want to put it. So this is the Lambda Island app. The user.clj file is not under source; it's under env-def, I believe. Oh, it's just under def, yeah. So this is a directory that only gets added to the class path during development, because this user.clj file, you actually don't want it in production, usually, but it's all kind of sort of helper stuff in development. So if I start a line REPL here, then my user.clj gets loaded, and let's see what I put a couple example things in there. Yeah, there's not much in here now, but basically the idea is that, you know, because remember that our workbench needs to be convenient and it needs to have access to tools. And so in that user.clj, you can put your own tools. This is stuff that automatically gets loaded, sort of helper functions. So I can show you, for instance, the user.clj for Lambda island. There's actually quite a lot of stuff in there, like migrating the database, enabling or disabling feature flags, hot loading dependencies. So this is a very useful one. So I can say, you know, yeah, let's say that Slack, CLJ Slack. Oh yeah, that's why I should have gotten online. I'll just quickly. Should be online pretty quickly now, if I'm lucky. Oh yeah, here we are. So I wanna try out this library. Well, what would you usually do if you're using Leiningen or you're using boot? Same thing, you know, you add it to your project.clj or your build.boot, and you stop the REPL and you start the REPL again. That's what you probably would do. But it's kind of silly, right? So why not have an add dependency function which loads that dependency, and you don't need to restart your REPL. And now I can require clj slack dot, what was it, users. So this is cool because it lets you quickly try out stuff, and if you're going to add more dependencies to your project.clj, then yeah, you can like immediately start using them. So this is powered by a library called. Oh, did I not reload this? Actually, yeah. So this is powered by a library called Pomegranate by Chas Emmerich. There's also a library called Alembic, which is even a little bit more high level. And Alembic lets you do stuff like reload all the dependencies in your project.clj. So you can, you know, you just put the stuff in there that you need, reload project, you're good to go. So it has this load project function. So that's the cool stuff to have in there. Is anyone using reloaded REPL, or are people using component or mount or integrant? Mount or mount? Also mount. Yeah. Anyone else? Okay, so maybe I should say a few more words about this. So when you're working on a project, basically the whole goal is you don't want to have to restart your REPL process, because you're in the flow, and you know, if you have 24 dependencies or maybe even more, restarting that REPL takes a long time. Reloading all that code takes a long time. And so, you know, you're in the heat of the moment, you're developing, and then like, oh shit, need to restart again. Okay, go make some tea. So instead, when things sort of get in a bad state, because why do you, okay, like if you add a dependency, that's one reason to restart. But another reason to restart is like, I'm redefining this function, but still it's not doing what it's supposed to be doing. Something went wrong. I'm just going to restart to make sure, right? This happens because when you get, you know, when you have stuff like records, multi-methods, it's actually a little bit tricky to make sure that, you know, like it doesn't get in a bad state. So there's a library, this is an official Clojure library, Clojure tools namespace, which lets you reload your code. So it actually undefines all the vars, all the namespaces, so they're no longer there, and then it starts loading them again. So you really get a clean slate. Now the problem with that is, say you're using HTTPKit or Jetty, you know, like a web server, and so you've given this a ring handler, which is a function, and so that web server is still running in the background, and it's still using the old version of the function. And you can redefine that 20 times, it's still using the old function because you never managed to point it to the new one. So that's a problem that you have. And so for this reason, Stuart Sierra came up with components. And with component, it looks something like this. Here's an example of a system using component, where I say, okay, you know, I have a web server, I have a web handler, I'm using a datomic database. These are like all these different components that need to be started or stopped. And it kind of figures out the dependencies. For instance, like my routes uses atomic, so it knows that it needs to start a datomic connection before it can start the routes. That's one of the things that that component does. Mount and integrant basically do the same thing, but with different syntax. And so what you then can do is say, okay, Clojure tools namespace, please unload all my code, undefine everything, stop all my state, stop the web server, stop the database, now reload everything, and I'll start everything anew. And so that way you get a really clean slate. And so this is more or less foolproof. This more or less always works and sort of gets you, to a point where you don't need to restart your REPL. You just say reset, give it 5 seconds, and you're back. And so those start, stop, reset, that's the kind of thing that you want to have in your user CLJ. Data helpers. So when you're working on inside a file, but sending stuff to the REPL, and you're trying out a function, and as long as your function, it just takes a few arguments, a string, a number, maybe a small map, like that's fine. But what if you actually need to pass it a ring request, which is already pretty complex. There's also already, there's like headers in there, a body, all kinds of stuff. If you need to type that all out, you're gonna get it wrong, and it's painful. So you should have ways, because that's something that, it plays a prominent role in your app. You have maybe dozens of functions that take a ring request. So you should have a way to very quickly get a ring request so that you can do something with it. And so what I, for instance, did in the Llama Island app is in development mode, whenever I make a HTTP request to the app, it stores it in memory. And from the REPL, I can always ask, okay, what was the last request? And I get this ring request map. Or what was the last response? Or what's the current session? And so this is super powerful, because you can it's powerful because you can inspect it. You're like, oh, I did a request and I'm not getting back what I want. What's actually in there, and then you can pass it. And so that's really nice. Similarly, all this stuff also is valid for Clojure script, right? Who's doing Clojure script? Yeah, so small half of the group. Say you're doing reframe, you could access your reframe database, get stuff from there. Access to your datomic connection, datomic database. These are all kind of the helpers that you want in there. So these are some examples of that. Get like the request to response, the session ID, the session. Once I added those, I was like, oh, why didn't I think of those earlier? Like this is so obvious in a way, so useful. Now this is good for the big stuff. Like a ring request map, it's a big thing, sort of a global thing. But another problem that you have, let me find some kind of namespace with a bit of code. No, it's actually the opposite of what I want. What else do I have? Oh, import should. Okay, so say I have a function like this, and I actually want to try out this, I want to evaluate this map here, but if I try to evaluate this, it's going to tell me, oh, message is undefined, TS is undefined, inst is undefined, right? So if I just want to try out sort of, one small, or say I want to make sure that this format inst day is doing what it's supposed to be doing. But then I need to know what to pass in there. And so I can do a couple different things. I can say, okay, def inst, something, and then just evaluate this where it is. Once that inst is defined, I should be able to evaluate this. Or I can copy this, and then maybe like wrap it in a let, right, and then try that. So these are all valid things, and I do those sometimes. Now there's a really cool library called Scope Capture, which solves exactly this problem. And I'll demonstrate that here. So say I have a function, you know, do the thing, ABC, and it kind of, I don't know, just kind of does a little bit of math on there. So do the thing, 5, 6, 7. Now, if I try to evaluate this BC, it tells me unable to resolve symbol B. Now what I can do here is, so I already, I loaded Scope Capture actually in my user namespace. So I can say, no, actually, no, it's not defining user. I can do it here, require SC API, ZC. SC spy. So I wrap this little bit of code in a call to spy. Redefine this function, call this again. Does the same thing. But if you look at the REPL, some stuff showed up. So when I originally evaluate this function, it tells me at code site -2 will save scope with locals ABC. So it's basically telling me that, okay, this call to spy, I've given it number -2. Now I call this function and it says at execution point 2 of code site -2 saved scope with locals ABC. So the place in the code has number -2, and the time that I evaluated this has number 2. When I do it again, it has number 3. So now I can do cool stuff, because when I say SC let SC say number 3, now I can actually call, use these locals ABC because it captured them, and inside this let SC block, it makes sure that those are defined. Is that clear? Does that make sense? So what you can also do, so yeah, now I can actually, if I want to test this plus BC, now I can do that. Oh, plus BC returns 13. Oh, interesting. You also have a def SC 3. So now it's actually defined A, B, and C, so that I can actually go in here and like evaluate these individual things. So that's a super useful library. Recommend checking that out. Yeah, so here you see it again. It says, okay, code site -1, execution point 1. It also, the thing that you wrapped in spy, it prints the result of just the thing you wrapped in spy also to the REPL. So that is also useful. Instead of wrapping this whole outer thing in spy, I can say SC spy just this inner thing. And now when I evaluate this, it tells me that plus BC is 13. And then yeah, I can do let SC, get those values back. Okay, next tip. So yeah, this second part is just sort of a loose assortment of tips, right? Now this one, I don't know, has anyone seen the talk by Stuart Holloway where he talks about his REPL workflow? So Stuart Holloway and apparently also Rich Hickey, it seems from the times that they've talked about this publicly that they have this habit of just having these big history files where they type in code, and this is kind of, you know, and they work with a REPL, and they never delete stuff from it. Like this can be thousands of lines long. Basically, you know, anything they've ever done with Clojure, it just kind of gets appended to that file, and they can always go back and scroll back and see what they did. And so I really like this idea, but I found it hard to sort of figure out, okay, you know, then where does that file go, and what exactly do you put in there? So I kind of came up with my own system, which is that for each project that I work in, I create a REPL directory. You can also call it a scratch directory. And then when I start working on a specific task, say I'm going to use this HTTP API, or I'm going to try to export some stuff or whatever, like I create a file for that topic. And so you can see some of those here. So this is for the Lambda Island app. So for instance, here's like all stuff that has to do with video representation, saving videos to the database, loading videos from the database. This has to do with episodes, with team subscriptions. This is a third-party API that I was trying stuff out with. And so these are files. They're not on the class path. You don't load these. They're not namespaces as such, but they're just sort of a history of stuff that you've been doing. Here's another. So I've been, you guys might know, so there's the Clojurian Slack, and there's this log for it. So this is kind of the history of the Clojurian Slack. Now I've been writing an app to replace this. It's on GitHub, Clojurian's log app. And so here I also checked in this REPL directory, and so you can actually go there and check out and see the kind of stuff that's in there. So for instance, this import file, so yeah, currently that's about 400 lines long, and it's just kind of loose things. You know, there's a lot of experimentation here. I kind of printed out some of the data that I got back from the Slack API, all message keys, some helper functions, and then some of this stuff, you know, it'll end up getting copied over to actual production namespaces or to test namespaces. And so I like this for a couple reasons. Yeah, I like to check it in if possible. This is not always possible. Like, you know, if you're working with a team, maybe that's something that they frown upon. It's like, okay, this is not real code. You shouldn't put that on the repository. But talk about it with people, see if you can, or otherwise, you know, maybe keep your own repository with these things. Why is this good? A, it encourages experimentation. So to sort of, you know, go ahead, make a mess. Because if you're typing stuff in production namespaces, you're always like, oh, I need to make sure I delete it afterwards, and you know, like, no, here you just try out whatever you think is interesting. It explicitly keeps that history for yourself and for your colleagues. It shows your thought process, sort of, you know, the different things that you tried as part of, and especially when you commit this together, right? So when people look at your changelog, they can like, ah, he was working on this feature, this is the stuff he tried, and this is the code that came out of it. It demonstrates how to use the stuff that you're building. And it provides a home for useful snippets. So one example of this, I have some code here, some pretty big, yeah, something like this, where it's actually, because, yeah, to give you a little bit more background about that, Clojurian's demo, log demo data. This is a subset of all the logging data, and I needed some code to generate this. Now this is something that I'm not going to be doing every week. So it's actually something that usually I would have just done once and thrown away. But then maybe sometime later I actually do want to redo this because, you know, something changed or whatever, and then it's kind of nice that I still have that code around. So yeah, just REPL scratch files, and I'd love to hear what you guys think of this idea. And then finally, tests. So yeah, there's this so I come from the Ruby community, which is like, you know, test, test, test. People are obsessed with tests. For good reason, you know, like, and they're very good at this. They have very good tools for testing. They're very good at writing tests. Clojure people also write tests, but it's a very different culture around testing, partly because there's much more of a culture around REPLs. So people use REPLs to get feedback while they're doing their coding, and not so much their tests to get feedback. But you still, at the end of the day, want tests, you know, because unit tests are important to make sure you keep the quality in your code base. So how do we bring these two together? So in a way, when you're using a REPL, it's a lot like writing unit tests, because you're constantly evaluating little pieces of code and then looking at the results. But instead of having it automatically, you know, you're doing it yourself. You're like, okay, run this, what does it look like? Run this, what does it look like? So if you kind of keep this in the back of your mind and you use this stuff, like, you know, say I have my do the thing function, and you know, when I call this IR65, okay, that looks right, but then if I do this and sort of keep it around, you know, like maybe with some different values, then afterwards, you know, I can copy these lines, move them to a test namespace, and turn them into tests. Yeah, now that's a test. So I think that's something, and I'm still working on like getting better at that myself, of really making that part of your workflow, of sort of being conscious of, okay, you know, like you're working in these REPL files, or you're working in your implementation files, at the bottom trying stuff out, already think of how is this going to look when it's a test. And so yeah, if at the, when you finish up a thing and you're like, oh, actually I don't have a lot of tests for this, well, go back to your Scratch file, to your REPL file, see all the stuff you did. Maybe half of that you can just copy over and turn into tests. So that's just an idea I want to put out there. And that's all I have. I'm very happy to take questions, and I'm also very happy to discuss this.
Thank you.
Thank you.
It was very useful.
All right, cool. Any questions? I'm just going to sit here until I get at least one question. So.
With the scope capturing library, how do you control the number of histories that it captures, so it doesn't like fill up your RAM?
Yeah, good question actually. I don't know if there's really. I mean, it's something that you mostly use in development, right? Like, and so, yeah, no idea if there's any way to say like purge this. I think it just keeps it in memory until you restart.
Very good.
Maybe they could have, if it is not already the case, they could have a spy once function. So that when you run your full program, you get off spy the last, so you get only the last version.
That's actually a good idea. Yeah, it could be a good addition. I mean, I'm assuming this gets stored in an atom somewhere. Let's see what spy. Well, yeah, of course these are funky macros. Spy init. Yeah, I don't know, but I'm 90% sure if you look around the code somewhere you're going to find an atom. So if that's really a problem for you, if you're like, I need to be able to clear this out, find that atom and reset it.
Okay.
Yeah.
That's very impressive, because I would need this feature a lot, and I am wondering how this function was implemented. I will take a look in the source code.
Oh yeah. Actually, I also haven't really looked at it much. But so yeah, it's a spy macro, which seems to use this spy emit helper, which is in the implementation namespace. I don't know if we really want to dig in very deep into this, but let's have a quick look if there's anything cool there. So spy emit, here we are. So it seems this is the main macro expansion. So it also captures any exceptions around there. And then I guess save and log is kind of the main thing. Now what I'm curious about is where it gets the locals, right? So local names comes out of the CS data, make CS data. What's make CS data? Extract local names. Extract. And this is a multi-method. Yeah, I'm guessing there's some pretty funky meta programming, but I'm assuming, can we find an ampersand in here? No. But yeah, so when you expand a macro, there's this environment that you get. Yeah, see here, ampersand env. This is your macro expansion environment, which yeah basically contains all kind of state from the Clojure compiler. And so I'm guessing, you know, you can poke in there to find the locals.
I have a small question regarding storing the REPL with your commits. Obviously, just to make sure that there is no personal data which is linked into the commit, you have to read again what is committed there.
That's actually a good point. If you're dealing with sensitive or private data, you should be a little bit careful of that. But that's also a good opportunity to maybe create some helpers that obfuscate your data. So when you're like, okay, you know, I wanna pull out some stuff out of my database so I can have some data to work with, but you know, change the names into fake names and change the emails into fake email addresses. I've written functions like that, so you can find lists online with like common names, you know, and just sort of generate some fake data, but have the rest. So you know, like take real data, but then replace all the sensitive parts, so that you have some stuff that you can give to people that they can play with. So yeah, today I'm here and doing this talk, but like in general, when the Clojure Taiwan meetup happens, is there always a presentation, or like do you just sit around and do some hacking, or what's sort of the format for the rest?
Free discussion.
Free discussion.
So some people prepare some things to present as well, and we discuss about them.
Okay. All right. Well, I guess I'm done, but I'll still be here. I need to leave a little bit before 5, so I'll still be here for an hour and a half, and happy to talk about any of this.
Cool.
All right. Thank you very much.
I've noticed a small typo in one of the slides.
Okay. Which one?
Let's try to.
Oh, Joanne already mentioned that, and I didn't. That's true. I didn't fix it.
Comfortable, I think it's CON, but I'm not sure. Need to check this.
This one comfortably?
I'm not sure.
This is correct, I think.
Ah,
Yeah.
okay, then I'm wrong. Sorry.
Okay. Yeah. Thanks. Nice. Just move to that side so I feel a little bit less in the spotlight.
现在就自由讨论，然后看有什么问题要问阿伦的话，就那请教一下，但是看大家可以